Today we're going to take a look at solving equations, exponential equations using logs. So up until now we solved ones like maybe it was 4 to the x equals 8, and we rewrote these with a common base. So we said, well, 2 squared is 4 to the x. And then we said 8 was 2/3. So we multiply exponents. So this is 2 to the 2x equals 2 to the 30. So now we'd say 2x equals 3. So x equals 3 over 2. But we came into some problems when you couldn't have a common base. So we're going to take a look at this one. So these first ones here when logs are on one side. So 3 to the x equals 11. We can't rewrite these with a common base, so we'll rewrite it as a log. So this would be log, I'm going to put the x first. We solve for our exponent, so x equals log base 3 of 11. And so then we can go to our calculator, and I'll show you where to go on both of them. So let's see. On Desmos here, bring this up. Our log key, I believe it's under Functions, Miscellaneous. There's a log, and it does your base. So base 3, arrow over of 11, and it tells us it's 2.18. If we were to go to our calculator here, if you're using one of the Inspires, just go to your scratch pad, and then your log key is in blue. So Control log base 3 of 11, and we have 2.18. So you'll want to get comfortable with those keys. We'll be using them quite a bit. So x equals 2.18. So this next one, again, logs are on one side, so we solve for our exponent. So we have x plus 1 equals log base 2 of 5. So then to solve for x, you'd have to subtract 1. But remember, log base 2 of 5 is a number. So when we enter this into our calculator, log base 2 of 5, arrow out of that, minus 1, and we have 1.32. So the last one with logs on one side, you'll notice the variables on one side. So 3x equals log base 6 of 81. So divide by 3. So x equals log base 6 of 81 divided by 3. So if we go to our calculator, I'll make the fraction key, and then our log key. So log base 3 of 81 divided by 3. 1.33. So when we move to these next ones, you'll notice there's going to be x's on both sides. So we're going to use one of the properties of logs here. So we're going to common log each side. So just log base 10. And I'm not going to write that 10. So log base 10 of 5 to the x minus 1 equals log base 2 of x. And the nice thing here, not log base 2, log base 10 of 2 to the x, we can use that property that our exponent comes out in front. So we have x minus 1 equals log of 5 equals x log of 2. So now we have to get logs, x's on one side. So we're going to need to do some distributing. So x log 5 minus log 5 equals x log 2. Well, let's minus the x log 5 off of each side. And remember, we can't just subtract those to x log 3 because those logs, they're not at that even scale that we found the other day. So negative log 5 equals x log 2 minus x log 5. And then we can factor out that x. So x log 2 minus log 5, negative log 5. You might say that that's 2 over 5 and go back to division. You could do that, or we could just divide by log 2 minus log 5. So this is a longer one for sure on the calculator, so make your fraction key. So we have negative log, we can ignore the base because it's base 10, so it'll fill it in automatically for you. I guess not ignoring it, it just automatically does base 10 if you don't write it. 2 minus log 5, and we have 1.75. I guess that would be 1.76 if we were rounding. So on this one, x equals 1.76. So let's take a look at a second problem here. And this one's actually supposed to be, let's rewrite this as 2 to the x minus 1. So x's are on both sides, so we're going to start by logging both sides. So log 3 to the x plus 2, log 2 to the x minus 1. So we can bring that out in front. So x plus 2 log 3 equals x minus 1 log 2. So then we're going to have to do some distributing. So x log 3 plus 2 log 3 equals x log 2 minus log 2. And now we got to get our x's on the same side and our logs. So I'm going to subtract the x from that side. And it doesn't matter which one. I'll subtract the 2 log 3. So now we have x log 3 minus x log 2, negative log 2 minus 2 log 3. Factor out the x. Again, it's a lot of writing on these. And then divide by log 3 minus log 2. You could condense them if you wanted. That's up to you. So now it's time to type this massive thing into our calculators. So we have negative log 2 minus log 2 log 3. And then we have log 3 minus log 2. We have negative 7.128. We could always double check that. We could go back to our problem here. And let's see if I can pull it up here so you can see it. We could go back and we could double check that. So is 3 to the power of plus 2, is that equal to 2 to the power of minus 1? And we have the same thing, so we got the right answer. So the last thing we're going to look at, we talked a little bit the other day about this number e. Kind of like the common logs, it shows up quite quickly. So all a natural log is, it's log base e. So if you have log base e of x, that's the same as the natural log of x. So what we're getting to here is on some of these, if we were to solve this, we could do it two different ways. So we could say log base e of 1.53 equals x. So this is really the natural log of x. Or we could log each side. Log of e to the x equals log of 1.53. So x log e equals log 1.53. Divide by log e. And we would have the same thing. So this just turns out to be the natural log of x. So if we go back to our calculator here, let's see, natural log right here of 1.53 is that. And the other way, so let's see, we had the log of 1.53 divided by the log of, and your E key is right here, and it always comes with a power. Whoops. Put in the control, so e to the power of 1. And we have that same thing. So 0.425. So there are multiple ways that you can solve these. A lot of times with e, natural log is a lot easier to use. So for example, this next one, I see that it's natural log of e, but we got to get that by itself. So let's see, what do we have? 6.25, oops, divided by negative 16.25, negative 0.384. And I would write this is really log base e of x, negative 3.84. And if we convert it to an exponential, e to the negative 3.84 equals x. And then you could just type that into your calculator. And I'll leave that up to you. So this next one, the natural log of x equals 2.3. Let's rewrite it as a log. And then, so this is e to the 2.3 equals x. And once again, you can type it in. So let's look at this last one. How are we going to find the inverse? So we switch our x and y's. Well, we got to get that exponent by itself, so times 3 on each side. So 3x equals e to the 2, oh, that should be y. So let's see, let's log each side. So the log of 3x equals, well actually, we got an e here, so let's natural log each side. Natural log of 3x equals the natural log of e to the 2y. So we can bring that 2y out in front. So let's divide by 2 and the ln of e. So we have the natural log of 3x divided by 2, the ln of e equals y. And the natural log of e is 1. So I'll show you that right here. Because if we look at that, the natural log of e is evaluating log base e of e. We want to know what that equals. Well, e to the x equals e, so e has to be 1. So this is really the natural log of 3x divided by 2 is y.